Okay, so like it was said in the introduction, I used to work for GeoCat, also as in the depth of DevOps field. Now I'm independent, but I'm here with the acknowledgement, with an acknowledgement to GeoCat, as they have sponsored the work that I presented, also non-disclosure agreement in the middle. So I'm just presenting what I can with the permission from GeoCat. And also this work was sponsored because of the GeoCat Live product, which is the online platform of GeoCat, where you can have GeoNetwork or GeoServer deployed in the infrastructure of GeoCat. So it's managed by GeoCat, and therefore it's a bit easier than you doing everything by yourself. So I recommend this product. So I'm also, this work was done together with Juan Luis Ponce, which is staff from GeoCat. It's also the major admin. And who knows GeoNetwork? Only 2, 3, 4. Okay, I was expecting a bit more. So GeoNetwork is a system for metadata catalogs. So for example, in Europe, we need to put all the data online. By the government demands this in the Aspire directives. So we also need to create metadata that describes the data. And GeoNetwork is one-stop application for this. You have a nice GUI, you have a system, it provides the metadata as a web service, and people can use it. If I knew there was so little knowledge of GeoNetwork, I would put here a print screen, but it has also a nice GUI, believe me. So the objective here was simply to scale this system. And we all know that traditional systems have a lot of problems with single point failures. If you want to scale your server, you need to put it down, change configurations, restart again. If you have a lot of people suddenly using your server, I'm talking more about the physical server under the desk or a bit like this, or a virtual machine on the cloud, it always gets a bit complicated because people start accessing your system and then gets clogs and causes a lot of frustration. So nowadays, since everyone goes crazy if the internet goes down, or the website goes down, or the email goes down, of course, we have even more demanding requests for our systems to be keep going and keep running, like no downtime, all the time working non-stop. Now actually I had to deal with a customer that wants 9.99999. So it's like 1 hour of maintenance every 3 months. It's complicated stuff, so this is the situation nowadays. This is what you need to achieve for multiple systems, not only for GeoNetwork, for everything in general. So a bit back to GeoNetwork. GeoNetwork is multiple subcomponent application where you, for example, you have the GeoNetwork that is more or less the GUI, and then behind you have the database that stores some information. You have the Elasticsearch that is used for indexing the metadata records, because when you want to search, we simply make a query to Elasticsearch and everything appears in the GUI. We also have a Kibana instance on the system for visualization of statistics. And also now we have the OGC record service, which is the new standard for distribution of metadata. So let's imagine that when I talk about GeoNetwork, we talk about a cluster of softwares that have to work together. So like I said, user goes to the website, puts there the metadata or edits the metadata, goes to the Postgres, Elasticsearch, and we also have file storage that in my case is going to be S3 storage because I'm talking about cloud. So continue ahead. So Kubernetes. So if you know what a Docker is and a container is, so Kubernetes is a platform where you can run your Docker images, Docker composers. But it's a very complex platform because it takes care of a lot of things for you, like restarting pods, internet traffic, scalability, security sometimes, and it can be very complex to learn. It takes a bit of time, but it's worth it. And also there's another advantage that if you learn this Kubernetes platform, if you go to another project that is also using Kubernetes, you immediately understand what's going on. It's not that there is a server under the desk, some system admin did something, you arrive there and you have no clue what's going on. So if you know a bit Kubernetes, you already know how the deployments are done and what is the philosophy. We call the DevOps philosophies. So like I said, this sort of platform that runs the Docker has a lot of advantages, despite being complex, is that, for example, if you have a Docker container that fails, it restarts. You can scale it. For example, if you have a lot of requests to the system, you start to have more and more containers doing the output. Multi-cloud, Amazon, Google, Oracle's, no major problems. And also we have a very, very efficient resource optimization, because we specify, for example, how much memory in CPU a container can have. So you can have 500 milli-CPUs, 1.5, or you can say go to a peak of 2 CPUs. This is very tight and very well controlled. These are the benefits for having to learn and spend a lot of time learning these things. So jumping here a bit, inside the Kubernetes, there's a philosophy that the containers are ephemeral. You start, you kill them, not much a problem. But in certain situations, for example, in databases, this is really complicated. So Kubernetes has a different deploy system called stateful set, where it keeps a bit of information on the deployment and pod identification. This is just a tiny remark. So like I said, for example, when you're doing a deployment of GeoNetwork, you need to configure the database. And all of this is configurable in a YAML file that pulls the information of where is the Docker image for something. And for example, on these YAML files, on the Kubernetes, we define, for example, the database is going to have here 1 GB memory and 1,000 milli-CPUs. So basically 1 CPU. And you can do like the normal request, what this container can have, and also a limit, meaning if the container starts to have more requests or more work to do, it can get a bit more memory or CPU, and then it stops. This is actually very important if you have stack overflows or too much memory consumption, because there's a limit, and when the pod reaches that limit, okay, it stops. Otherwise, it will continue till it sucks all the memory, everything collapses. Like I said, also in GeoNetwork, we also have to have, for example, Elasticsearch. Elasticsearch is for indexing metadata. It's very well-known software. It also consumes a lot of memory. And in this case, for example, in Kubernetes, it makes it easy that it runs as a cluster. So we could have 2, 3, 4 instances, and they all share information between them, and you don't have to worry a lot. Scaling, okay, it's here another example of configurations that you normally do in these systems. So, this issue with the scaling is that you need to configure how the system is going to detect that it needs to do a scaling. Meaning, okay, either the Docker image or the app is using too much memory, or you have too many requests, or the CPU usage, it's infinity. Yeah, you have a lot of parameters that you can use to decide that the system is under stress and you need to scale it. And I'm talking by scaling, I mean replication of the software that you're running. So for example, here's an example of replication that I simply can do in Kubernetes. This is a configuration file saying, okay, if the CPU is above 75 on one of the pods, start adding pods with the same software. And of course, and you also can configure that then after 5 minutes, if the CPU usage is not 75%, then you start killing pods. And this is the beauty of the systems of Kubernetes, is that this is all automatic. You don't have to worry much about this. And of course, if you're working on cloud systems, of course, you're saving a lot of money because if, let's say, suddenly your website or your system appears on the news, there is a massive peak of people trying to access your system. Kubernetes simply starts scaling everything for a couple of minutes. And then when the news broadcast finishes and everyone goes to do something else, your system is scaling down, saving you money, okay? So this is something really, really important in Kubernetes and why it's so popular with DevOps. Okay, this was an example. So also the system of Kubernetes does a lot of traffic control because the traffic goes, let's say, to an ingress, and then from that ingress it goes to a service and then to pods. And we could do a lot of tricks in front of our applications, like sticky sessions. I'll explain a bit what is this. User login, controls, cores. It's always the cores, if you know what I mean. A lot of, for example, HTTPS. You don't have to worry about these things because the Kubernetes takes care of all of these. And sticky sessions is something important, and I'm going to explain what it is. It's like, for example, if you have two users, user one, user two, they can be in different computers, different places. And let's say the traffic for user one goes to a specific container. The traffic from user two goes to a different container. So it makes a sort of automatic load balancing without you having to care much about this. So at the end of the day, it becomes a bit easier to do all these internet tricks when you know it. So talking a bit back to GeoNetwork, things that you can do like in the Kubernetes, like for example, GeoNetwork needs a folder to write files. You simply could put this folder instead of a file system, you can put an S3 bucket, and all of this is shared by multiple instances. So of course, when you do the scaling, you don't have to worry about much because everything is being read from a common file system that is managed by normally one pod, but okay. Then, for example, this is a bit more technical on the side of GeoNetwork. So because GeoNetwork has a GUI, has HTML, has JavaScript, has also a website. So you need to build all of this. You need to, there's these typical builders in Node.js and other systems that develop that get all the CSS, all the HTML, bundles everything together. And this tends to be a big nightmare on Kubernetes because let's say if you have two applications, two pods, when they both start at the same time, they start building all this code internally on each pod, and it could have there diversions of the name of the files because normally you put a number after the file for identification, and this can get really tricky with these builds. So you had either to disable or, for example, put this in a sort of memory cache so that everything gets shared between pods. So some tricks. Also, when you're working on Kubernetes, like if you're using S3 buckets, like mounting a remote file system can sometimes give problems. The connection, the IP range, credentials, we've been through everything. Timeouts, so you also have to apply specific scripts to see if things are working. And then also other problems that you may have when you have multiple pods doing the same software is like, for example, on GeoNetwork, we have a metadata harvest. It's like you can program GeoNetwork to say, okay, go to the website of this organization that also has a metadata catalog and fetch me all the metadata records that you have there. So we call this harvesting. So the problem is that if you have 4 or 5 pods or applications identical and doing this at the same time, you're going to have a lot of confusion. Okay? Too many chefs in the kitchen. So you have to do things like only one application is like sort of the main application is going to be doing this operation. thankful that GeoNetwork allows this with some configuration streams. So this is really good. So only one GeoNetwork instance can do this work. It fetches the records, and the other ones are all happy using those records. So only one chef in the kitchen. Again, talking about scaling, a bit explanation. The thing, why do I have this slide again, is because normally auto-scaling comes out of the box in Kubernetes, but we simply use this system called CADA that is way more advanced for scaling and way more configurations, but this was just a remark. Okay, so when do we need scaling and when do we not need it, or if it's, we call it vertical scaling or horizontal scaling. Because when you need to scale a system, you can do two things, horizontal or vertical. So vertical is like when you add more CPU, more memory to an application. So you restart, you get, for example, more 2 gigas from the cluster, you restart your pod, and then you work with 4 gigas. That's called the vertical scaling. And yeah, it's more used, for example, when you have databases or more databases, I think. GeoServer also, Java machines tends to be. Or, yeah, and normally it's like you need to restart the system, and so you have, let's say, new hardware. This is the vertical scaling. And then you have the horizontal scaling that has been what I've been explaining here, that is simply putting more applications working with identical resources between them. So, yeah, and this is exactly what we want to work more in horizontal scaling, because you have there a high availability and a sort of prevention of problems. Because if you start replicating pods with the same software, what you can do is that the traffic goes to one pod, another one is replicating, the one that is starting doesn't get any traffic, then the traffic goes to the new pods, and then the old one can be shut down. So this is very interesting because of reliability, this horizontal scaling. So you can have multiple pods, one's going up, down, changing configurations, but the traffic is always constant, going to a working pod. This is very good in Kubernetes, and this is why we apply Kubernetes technologies and use these platforms. Okay, so a third part of this presentation was like a sort of also talking a bit how to do benchmarkings. And in GeoNetwork, being a metadata catalog and having metadata records, one way to benchmark this is like getting metadata records from the server itself. And this was a sort of test setup that me and Juan did for seeing how things scale, because one thing is that you program the scaling, one thing is to see it scaling. And normally this you do with these sort of stress tests. Yeah, and with explanation, it was basically getting a website from GeoNetwork and see how fast it goes, the resources being used, and of course to see this scaling. Okay, configuration, and yeah, I simply didn't put here the graphics because it was a bit too much. And for example, what you see here is like on the left, like a number of users trying to access the system. Well, we're faking the users because it comes from one computer. And then, of course, as you have more users, you have more GPU user, more memory, a bit more time being how can I say, to load the pages because it starts to get into acceleration. But basically, on current GeoNetwork instances, you can go to 18 requests per second, 60 requests per second. We also had a single GeoNetwork installation can have like 100 users at the same time without major problems. And yeah, and this was also to test the feasibility of the Kubernetes, because when you start more users, you start to also have more pods. So all of this I explained here. It was also developed for GeoCat, because GeoCat has this production-ready products? Yeah, cool. So I'm on time. And yes, this, what I talked here is a bit technical, but it's being implemented on the GeoCat Live platform. It is a platform, a cloud platform for GeoNetwork. So yeah, if you get this service from GeoCat, you have all these Kubernetes behind, taking care of scaling and all problems, from SSL certificates to domains, and zero downtime, because yeah, it's on Kubernetes and GeoCat is managing that for you. So yeah, slide was not supposed to be here. Oh, I think there was a problem in the order of slides, but it doesn't matter. So when I was talking about scaling, I should have shown this slide, because here's a compilation of resources needed to run GeoNetwork as a reference material from the sort of benchmarkings that we did. Like, for example, you should always have 2 pods, because then it's 2 applications running in parallel. If one goes down, you still have the other one getting traffic. Your users have no idea what's going on, and everything is working pretty well. Then, of course, yeah, more requests, more users, more pods, more memory, more CPUs. This is the idea. Things that we've learned on applying, Kubernetes for GeoNetwork. Scaling works pretty well. We have problems with the HTML builds when the pod starts. Bucket mounts sometimes fails. You have to pay attention. You have to pay attention for gathering records. We call harvesting. Performance, yeah. It worked pretty well, because GeoNetwork is sort of monolithical also. Yeah, so this is it. So, yeah. I think the best conclusion was that horizontal scaling worked pretty well for GeoNetwork, and yeah, and you should also see the talk of Jody this afternoon on GeoServer, the state of the art. I know he's not going to talk about GeoServer clouds, but part of this job also involved the scaling of GeoServer, because there is a new GeoServer specific for cloud systems that it scales pretty amazing. Okay, ci sono.
Thank you so much. We have a few minutes for questions. Does anyone have any questions for Josh? I have a question if no one has a question. So I was just wondering, have you open sourced the Kubernetes configuration for this deployment? Or do you have any plan?
In the beginning, there was a non-disclosure agreement.
I have a follow-up question. I guess I was just going to ask, have you kind of packaged the entire system up as a single Helm chart? How do you manage that?
With a lot of pain. So for those not familiar, the Helm chart is a sort of package management on Kubernetes. So when you want to install an application, simply write in the command line, it goes fetch from a repository as a package and installs everything. So yeah, this was all built with Helm chart, with each component being a subcomponent inside the Helm chart, and everything being pulled and run immediately, just one command line. And it was really, it was the hard part of this work. If you would work with Kubernetes, you understand a bit better why this is so important on having a very good package and everything already working,
Yeah, definitely. Cool. Thank you so much. Are there any other final questions? Yes. Oh, I'm sorry, do you mind if I just give you the microphone for recording?
You mentioned Kubernetes being pretty complex. You got any thoughts on if you need to scale containers, do you recommend just jumping straight into learning Kubernetes, or are there maybe some intermediate steps to other more simple scaling things?
There's always 1,000 ways to skin a cat. There are easier technologies like Docker Swarm that is more basic low level, where you say to Docker itself, okay, start multiple containers. There's also then on the AWS infrastructures that you can press a few buttons. But at the end of the day, this is still the best, okay? But then the complexity depends on how high you want to reach the level. Okay, if you just want a simple deployment, it's a couple of YAML files. You can ask ChatGPT on AI to do this for you. But yeah, and then as your case goes more and more complex with scaling, then you need to study a bit more Kubernetes. So I don't know if that answers the question, because I keep forgetting.
Cool. Thank you so much. Let's thank Josh again.